Okay, so today we're going to talk about testing a hypothesis about a population proportion. So far we've just been testing hypotheses about population means. Okay, mu equals this, mu is greater than this, mu doesn't equal this. It's all been about population means. Today, it's the same concept, except we're talking about population proportion. Now, directing back to like our reading skills, there are key phrases that you should look out for to indicate whether you're testing a population proportion as opposed to a population mean. Okay, so some words that you should look out for would be like fraction. What fraction of a student's grades will be A's? What proportion of graduating seniors obtain jobs with starting salaries in excess of 50 grand? What percent? So when you see phrases like fraction, portion, percent, that means we are going to be testing hypothesis about a population proportion, not mean, proportion, okay? Those are the words that you should be looking for. So, testing a hypothesis about a population proportion, all right? So, first of all, the data is obtained via a random sample of size n, just like normal. The conditions for a binomial random variable are met, just like normal. There's a fixed number of independent trials with only 2 possible outcomes on each trial, blah, de blah, de blah. Now, here's where there is a main difference. When testing a population mean, we find the t-value for a test statistic. But now we're testing a population proportion, which means our test statistic is going to be a z test statistic instead of a t. But again, just like I did for population means, I'm going to give you templates. Okay, I'm going to give you templates. So, what I want you to do is we're going to come down to this example. We're going to read and decide what test I need to run to answer the question. So on number 1, a publisher reports that 63% of their readers own a particular make of car. A marketing executive wants to test the claim that the percentage is actually different from the recorded percentage. A random sample of 340 found that 58% of the readers owned a particular make of car. Find the value of the test statistic and round your answer to 2 decimal places. So, let's write down all of the information that they gave us. First of all, they said a publisher reports that 63% of their readers own a particular make of car. So that means my null hypothesis is going to be, and here we see percent, that my proportion is equal to 0.63. My proportion is equal to 0.63. That's what they're telling us. That's what they're reporting. Okay? Now my alternative hypothesis, did they want to prove that people actually had more, or they had less, or just different? Do you guys remember? Yeah, it literally just said they want to know if it's different. So my alternative hypothesis is just going to be that my proportion is different than 0.63. Okay, that it's not 0.63. Now, this information right here tells me that it's going to be a 2-tailed proportion test. Okay, 2-tailed proportion test. So I want you to go to your templates, and we're going to scroll down until we see 2-tailed proportion. Notice you don't have to determine if sigma is known or sigma is unknown. Like, that's not what they're talking about. Proportion is just 1-tailed or 2-tailed. So since it's not equal to, we're going to highlight this 2-tailed proportion and copy it. And we're going to come back here, and we're going to paste it in there. What's nice is it's also going to help me figure out what other information I need to know. Okay, so that means I have to figure out all the red things just like normal. I need my alpha, my significance, I need my p-value, my x-value, and my n-value. Okay, so let's read through the problem and see if we can find the rest of the information. A random sample of 340, what would that go in for? N, very good. Found that 58% of the readers owned a particular make of car. I'm just going to jot that down. 58% of the readers, so of the sample of 340, owned that particular make of car. Find the value of the test statistic, round your answer to 2 decimal places. So, what is my p-value? Did we figure that out anywhere? Yeah, it's at 0.63. They already said that we recorded it to be 0.63. Now here's the area that's going to cause a little bit of issue for you guys. The x value is sometimes hard to find, okay? The x value is in that sample how many people had what we wanted them to have. Well, they didn't tell us that. They told me that I have a sample of 340, and then they told me that 58% of them had what we wanted them to have. So what we're going to have to do is we're going to have to figure out x. And to do that, we're literally going to take 0.58 and multiply it by 340. Okay, 0.58 and multiply it by 340. Okay? So what I'm going to do is I'm going to put that information in quick. So p-value is 0.63. The x value, I'm literally going to type it in just like we said, equals 0.58 times 340. Okay? And then my n value is 340. So a couple things. First of all, you're going to notice that your x value is now a decimal. And you're like, we're talking about people. That can't happen. I understand that. Just go ahead and leave that, because what that'll do is that'll make sure that your p-value is exactly 0.5, or your p-hat, excuse me, your p-hat value is exactly 0.58. Like if you look down here, that tells you that your p-hat, so of the sample, is exactly 0.58. Even though it's a decimal, that's okay. Now, what information have we still yet to find? The significance level. Now, I want you to think, before we get all stressed about it, what are they asking me to find in this problem? The test statistic. Now, the significance level, that alpha value, is only used to find my critical values. Remember, because we find alpha, then alpha over 2, then we use, since this is a z-value, norm.s.inv of 1 minus alpha over 2 in order to find your critical values. Well, they didn't ask for the critical values for this problem. So actually, with this problem, the significance value, your alpha, it doesn't matter. It doesn't help us. We don't need that. We only need the test statistic. Is that okay? Because look, right now I have a significance of 0.1. I could change that to 0.01. Does it change the test statistic? No. I could change that to 0.5. Does it change the test statistic? No, not at all. The alpha, the significance level, does not matter here because we are not focusing on the critical values. We're not answering the question about, like, do we reject the null or fail to reject? They only want the test statistic, and the alpha has no impact on that. So to answer your question, because it says round to the nearest 100, or 2 decimal places, my z-value is negative 1.91. So I really just liked that problem because it got us in the habit of just writing down the information that we had and finding the information that we needed. Let's go to number 2. A hospital director is told that 54% of the emergency room visitors are insured. The director wants to test the claim that the percentage of insured patients is less than the expected percentage. A sample of 300 patients found that 150 were insured. At the 0.05 level, is there enough evidence to support the director's claim? So the first thing we're going to do is we're going to identify our null and alternative hypotheses. So our null alternative, or her null hypothesis, it says a hospital director is told that 54%, that percent right there tells me that it's a proportion. We're testing a population proportion. So my hypothesis, my null hypothesis, is that p is equal to 0.54. The alternative hypothesis has to do with what they're trying to find. The director wants to test the claim that the percentage of insured patients is less than the expected percentage. So what's my alternative going to be? P is less than 0.54. Very good. Now, tell me, does that mean I'm going to have a one-tailed or a two-tailed test? This is a one-tailed test. Specifically, is it left-tailed or right-tailed? This is a left tail, very good, because it's pointing to the left. So what I do is right away I go get that template. I know that I need a one-tailed proportion, so one-tailed proportion over here. I'm going to copy that. I'm going to come back and I'm going to paste it in there. And the reason I do that first, again, is because that helps me figure out what I need to find. So based on what I need in red here, I need my alpha, I need my P, I need my X, and I need my N. Okay? Alpha, P, X, and N. So my alpha is the significance level. Did they specify what kind of level I needed? It says at the 0.05 level. Very good. My p-value is the proportion. What p-value did they say we're working with? 0.54. And then the x and n value both have to deal specifically with that sample. The n is the sample size, so how many patients were in our sample? 300. And the x value is of that sample, how many had the desired results? 150. Okay? So what we're going to do is we're going to come put that information right here in my table. So significance of 0.05, P is 0.54, X is 150, N is 300. And it calculates everything else for you. So to calculate the P hat, that's the sample proportion. They literally just take X divided by N. What is Q? Do you guys remember? What is Q? 1 minus my p-value. So since my p-value is 0.54, to find my q value, they just took 1 minus 0.54. That's all the information that they gave me. So the question stated, at the 0.05 level, is there enough evidence to support the director's claim? Just like what we did, and by the way, if you'll notice, I have like 2 answers down here in boxes. We're going to choose one of those, okay? Just like we did with the population mean, there are 2 different ways you can figure this out. You could sketch a picture of your distribution here. Now, since this is proportion, this is a z distribution. If it was mean, it would be a t distribution. But 0 is still in the middle. And again, we said this was a left-tailed test. So what is the critical value that I'm focusing on here? Negative 1.39. So negative 1.39. Anything to the left of that is the rejection region, right? Anything to the right of that is the fail to the reject region. Now, where is my test statistic? Oh, sorry, this is not 1.39, is it? What is it? 1.64, my bad. What is my test statistic? Negative 1.39. So that's going to be over here. That's my test statistic, negative 1.39. So tell me, is it in the rejection region? No, it's in the fail to reject region. That means we are going to fail to reject the null hypothesis. What was the other way we could figure out if it was reject or fail to reject? What did we look at? The p-value. And if the p is low, the null must go. And if the p is high, the null must fly. So here's my p-value. Is it greater than or less than my significance level? It's greater than. So p is high, the null must fly, which means that we are not rejecting it. Now, since we are not rejecting the null, we have to figure out which one of these 2 answers is correct. There is sufficient evidence to support the claim that the percentage of patients insured is less than 54%, or there is not sufficient evidence. So what do we think? Do we have enough evidence to support the claim that the percentage of insured patients is less than 54%? No, we did not reject the null hypothesis. The alternative said that it was less than 54%. And did we have enough information to fail to reject? No. So the alternative does not stand. The alternative does not stand. So is there sufficient evidence? There is not sufficient evidence. There is not sufficient evidence. And again, if you're like, I don't understand, think about what they're asking. There is not sufficient evidence to support the claim that was made. And the claim that was made was that it was less than 54%. Our evidence showed that we failed to reject the null hypothesis. We're okay with the null hypothesis. So there is not enough evidence to say that it's less than 54%. Not enough evidence. Whew. All right, let's go one more. Let's go down to number 3. A sample of 1,600 computer chips revealed that 53% of the chips fail in the first 1,000 hours of their use. The company's promotional literature states that 50% of the chips fail in the first 1,000 hours of their use. The quality control manager wants to test the claim that the actual percentage that fails is different from the stated percentage. Make the decision to reject or fail to reject the null hypothesis at the 0.10 level. Okay, we have to be very careful with this problem, because the very first piece of information that they give us right here is about what? That's about a sample. So is that information, a sample of 1,600 computer chips revealed that 53% of the chips fail, is that information my p-value? No, that is about my sample. We have to read a little bit more to figure out what the actual p-value is. The company's promotional literature states that 50% of the chips fail in the first 1,000 hours of their use. So the company's promotional literature is saying, my null hypothesis right here, the proportion is 50%, 0.50. The company is saying that the population proportion is 0.50. Now, if we keep reading, what is the alternative hypothesis going to be? Very good. P is not equal to 0.5. They want it to be different. They didn't say greater than or less than. They just want it to be different. So is this going to be a one-tailed proportion or a two-tailed proportion? Two-tailed proportion. Let's go get that table, copy it over. And then we can fill in the information from there. So we need alpha, my p-value, my x value, and my n value. Okay, so a sample of 1,600 computer chips, what's that going to be? Your n value, very good. Revealed that 53% of the chips fail in the first 1,000 hours of their use. Does that number 1,000 go in for any of my values? No, it's part of what they're talking about. It's not one of my values. My next question is, though, what's my x value? How many of these 1,600 chips had that desired quality? 800 and what? 48? Where'd you get that? I don't see that anywhere. Good. They didn't give us the number here. They just said 53% of the chips. So you have to take for your x value 0.53 and multiply that by your sample size, 1,600. What's my p-value? Not p hat, p. 0.5. And then what is my alpha? 0.10. Be very careful, because a lot of times our significance level is like 0.01, 0.05. Sometimes they give you a 0.1. So be very careful with the placement of those zeros. So I'm going to put in my significance level here of 0.1. My p-value is 0.5. My x value is 0.53 times 1,600. And my n value is 1,600. Now this is a two-tailed proportion test. So again, if you want to sketch that picture, it's going to have two tails here. And my critical values are -1.64 and +1.64. Okay, and the rejection region's on the outside of them. And what is my test statistic here? It's 2.4. Well, that's going to be over here, 2.4. So is that in the rejection region? Absolutely. Here we are going to reject the null. Again, if you don't want to sketch that picture, what else can we look at? The p-value. And is this p-value greater than or less than my significance level? It's less than. And if p is low, the null must go. So we are going to reject the null. So I have a question for you. Is there sufficient evidence at the 0.1 significance level that it is different than 50%? Yes. Thank you. I had to get the words in my brain there. Panic.